1.
Hello, Rad Lab folks. It's the Vanna Lab of Rad Lab from Grove City College. That's a joke. It's a very bad joke. But I want to talk to you again about dealing with liquid waste, because I thought that this is a good lab to show how we deal with a liquid radioactive waste, and also to talk to you about how this first part of the experiment is going to proceed. So, here's the physics behind it. You'll see a little cartridge here. It's called a mini generator. And the mini generator is a liquid chromatography cartridge, which is an extremely useful and important technology in chemistry, but it has applications in physics too. And this little cartridge has a column material in it that binds cesium-137. So cesium loves to bind to this stuff. And the cesium in here is always decaying to barium. So the cesium-137 decays to barium-137 by beta emission. But it decays to an excited metastable state of barium. Now, metastable means that the decay from that state to the ground state of barium is not instantaneous. In fact, it has a certain half-life, and you're going to find that. That's what you're going to find in this experiment. Now, the key about this is that cesium and barium do not have the same chemical properties. And so what we can do is we can take a material, a liquid material, and this liquid material is composed of 0.9% sodium chloride, that's just standard table salt, and 0.04 normal hydrochloric acid, so it's a very weak acid solution. Now it turns out that when you flush that material through this column, the barium elutes off the column. Now it's going to go into one of these little dishes, and the cesium stays on the column, because the cesium would rather stay on the column than be in the solution. But the barium would rather be in the solution than stay on the column. And so the metastable barium, which is always being produced in this little mini generator, will come off into this little bottle cap. And then we will take this little bottle cap and we will take it to be read. Now, a couple of things about dealing with liquid waste. They do spill, and so I have some blotting paper here, and I think I'll put a little bit more. I don't really require a whole lot of benchtop paper for this. And the main reason for this, for one thing, is that this material has a very, very long half-life. And in terms of disposing of it, the usual rule is when something decays 10 half-lives, it is able to be disposed normally. And so by the time Mr. Fugate and I finish this lab, we'll have been well over 10 half-lives. And since it's just a slightly acidic solution of salt, we can just dispose it down the sink. But we have to wait for 10 half-lives. But when you're working with liquid solutions, you'll notice I have gloves on. Of course, we have our fearless dosimeters. And I need goggles, and I need long pants and closed-tip shoes for this. Okay, so then what we're going to do next is I'm going to show you how to do the experiment. So what we will do is I will take, if I can find the little, I think I can just do this. Where is it? I'm going to do it this way. Okay. I'm going to put some solution in here. And we're going to do this. And now what I want to do is to do a dry run. And so, well, we'll do the dry run in a minute, but I'll show you what we'll do here is we will take this solution and we will put it through this little column chromatography unit, and we will drip it dropwise into this material. Okay? And then when we are done with it, we'll do it slowly. And then when we are done with this, we'll take it to the gamma ray spectrometer to be counted. Okay, let's stop.